New computer simulations have shown that low-temperature hydrothermal vents could survive on the dark ocean floors of moons, like Jupiter's Europa, for potentially billions of years, sparking hope among astrobiologists that these alien oceans could be habitable. Hydrothermal vents provide both chemical energy and heat, and are one possible location for the origin of life on Earth. Planetary scientists theorize that similar vents beneath the icy surfaces of moons, like Europa, Ganymede, and Saturn's Enceladus, could warm these oceans and potentially kickstart the biochemistry of life. Previously, modeling efforts have focused on extremely high-temperature vents, known as black smokers, which are powered by volcanic activity and siphon energy from Earth's hot core. However, the icy moons lack hot cores, raising doubts about whether such vents could survive long enough to create stable conditions for life. Yet, super-hot vents are not the dominant form of venting in Earth's oceans. A larger volume of water passes through lower-temperature vents on Earth. The flow of water through low-temperature venting is equivalent, in terms of the amount of water being discharged, to all the rivers and streams on Earth, and is responsible for about a quarter of Earth's heat loss, said Andrew Fisher of the University of California, Santa Cruz, UCSC. The entire volume of the ocean is pumped in and out of the seafloor about every 500,000 years. Fisher led a UCSC team that modeled the proliferation of such low-temperature vents on Europa and Enceladus. Given the lack of data about the oceans on these moons, the team based their simulations on the circulation system in the northwestern Pacific Ocean, specifically the eastern flank of the Juan de Fuca Ridge. Here, cool seawater sinks and flows down into the rock in the seabed via extinct volcanic cavities called seamounts. The water travels through the rock for about 30 miles, 50 kilometers, heating up in the process, before rising through another seamount. The water gathers heat as it flows and comes out warmer than when it flowed in, and with very different chemistry, said study team member Kristen Dickerson, also of UCSC. These findings suggest that low-temperature hydrothermal vents could indeed exist and survive on Europa, potentially providing the necessary conditions for life to develop in these alien oceans. This breakthrough could redefine our understanding of habitability in the solar system and guide future missions in the search for extraterrestrial life.